Okay, so in the last class, we finished the fifth chapter along with exercises, and we started with the sixth chapter, another chapter called materials and its types, different types of materials. Okay, this we started in the last class. Yeah, we saw that there are three states of material. Okay, there are three forms in which something can exist. In which something can exist. Okay? Three forms are known as its states. Okay, states of a matter or states of a material. We talked about it, and there were three. Okay, like it can be solid. Okay, the solid form of the substance. It can be liquid, that is the melted form of something, and it can be gaseous, that is the evaporated or vapor form of something. Saw this. Then, then we saw about soluble and insoluble materials. There is some material, okay, or some components are there, elements are there that can be dissolved in a liquid. That can be dissolved in a liquid that are known as soluble. And there are some other materials, some other elements that cannot be dissolved, that cannot dissolve in a liquid, that cannot be soluble in a liquid. Those are known as insoluble material. Now, a large number of substances dissolve in water. Okay, a lot of substances are there. Okay, a lot of substances are there which can easily be dissolved in water. That is why water is known as solvent. Water is known as what? Solvent. Okay, why? Because it can dissolve a lot of liquids. Can I have a video on, please? Now, the mixture that we get after dissolving a material in water is known as solution. Is known as solution. Okay. So, suppose I have water. Okay. I have water plus I have sugar. When I'll dissolve it, I will have a water in which there is sugar. Okay, that is dissolved. So the water that I have will be known as solvent because water is called solvent since it dissolves many liquids. Okay, solvent. The thing that I will get when I have dissolved something in it, okay, will be known as solution. The thing that I am dissolving is known as solute. Okay, is known as solute. So when you dissolve a solute in a solvent, okay, that can be water. What you obtain after mixing them both is known as solution. Okay. Hi Abraham, good morning.
Hello, ma'am. Good morning. Sorry, I'm
Ma'am, can you
It's
show me the diagram of the soluble and insoluble substances?
Yes, Anna. Here you go. Now there are some substances which are completely dissolved in a liquid, but some substances which are insoluble, What happens to them is that they either float on the surface of water or they will sink down at the bottom of your water. Okay. they will not be able to dissolve fully in the water. For example, oil. When I put oil in a glass of water, it will first go down, okay, in molecules, like it will go down and then it will come up and rest on the surface of water. Okay. But when I put sand in the and then when I mix it or mix the oil, it will break down. The that single layer will break down. Okay. And then when I stop mixing it, it again will rise up and combine and form a layer on the surface of water. Okay. Why is that? Is because oil is not soluble in water. Okay. Similarly, when I try to dissolve dust in water, sand in water, I'll put the sand in the glass of water. The sand will sink down. When I try to dissolve it, it will like the water will look muddy and the sand particles will split. But then eventually, if you leave that substance there, then all the sand will again sink at the bottom. All the sand will again sink, but it will not be dissolved. Okay, so those are known as insoluble materials. Okay, insoluble materials. Now, now, do gases also dissolve in water or not? Like solids and liquids, gases are soluble in water. Some gases are soluble in water, whereas others are not. Okay, see, some solids are soluble, okay, can be dissolved in water. Some solids cannot be dissolved in water. What about gas? Some gases are there that can be dissolved in water, but some gases cannot. Usually, some gases dissolve in water in small quantity. In small quantity. An example is oxygen. Okay, an example is oxygen. We know how the animals living in the water breathe because they have small molecules of oxygen in the water that is dissolved in the water. Okay, small molecules of oxygen is there, which is dissolved in the water. When we have water, okay, and sea animals are there beneath the water, there is also small molecules of oxygen dissolved in that water that they use to breathe. So, yes, gases can also be dissolved in water. Okay. Now, materials that float or sink in water. Okay, so we saw materials right now that could be soluble or insoluble. Now, materials are here classified on the basis of their ability to float or to sink. Okay, what is floating is when the materials, they don't go in completely, but they just lie or they just float on the top layer of water or the liquid. And what is sinking? Sinking is when the substances, the materials that you put in something, they just go down at the bottom and then they just lay there at the bottom. That is known as sinking. So you can see that some objects here are floating in water, whereas some objects are sinking here. Okay. Now, you might have experienced in your daily life that some materials sink in water while others float. For example, when we put heavy objects in water, such as stone, iron, nail, needle, etc., they sink in water, whereas dry leaves, paper sheet, they float in water. Okay, then we have another types of materials based on the ability of light to pass through them or the ability of us being able to see through them. Okay, now those are three types: transparent, translucent, and opaque. Okay, what are these three? Transparent is an example can be a glass. Okay, glass that is fully transparent and you are able to see through. Okay, please turn on your videos.
Ma'am, just a minute. I'm having some internet connection. I'm just trying to figure it out.
Okay, man Abraham.
Yes, ma'am.
Video on, please.
Okay, ma'am.
Yeah. So I was saying that some materials you can directly see through them. Okay. They are fully transparent, means light passes through them completely, and the things are visible to you from the other side, on the other side of the glass completely. Those are transparent materials. Then there are materials which are known as translucent materials. What are translucent materials? Translucent materials are those materials which are not completely transparent but not completely opaque also. Like if you've seen the hotel bathrooms, they have doors. Okay, the shower gates and all are made up of translucent materials, translucent glass. Okay, you cannot completely see it, but it is a glass. Okay, that is not very transparent, but not very shut also, not very that also. Okay, that is an example of translucent glass. Translucent glasses also examples are window panes. Okay, we have window panes of transparent and translucent glasses. Then there is opaque materials. What is opaque material? Opaque is materials through which you cannot see at all. Okay, like a wooden door. Okay, a wooden door or a wooden window. Okay, something through which you cannot see at all. That is known as or opaque material. Let me show you all three of the materials. Abraham, is your connection okay?
Yes, ma'am.
Okay. Okay. Two things I'm gonna show it to you. Okay. Take a look at this first. The first one is holding a glass. Okay, and you can see his face through it, like it's completely visible. Look at the second one. She is also holding another type of glass through which you can see a little bit of it. Not very clear, but just the outline, a little bit of it. That is known as translucent, when only some light passes through. Look at the third one. It's completely hiding his face. It is the opaque material, like wood and all, through which no light can pass through. Okay. Now, this is the differences in how the materials look. Look at this image. Okay. See, in the first one, we have transparent. When you have a whole transparent glass or transparent surface, all light will pass through it. Okay, all the light will pass through it. When you have a translucent surface, only some light is able to pass through from the other side. And when you have an opaque surface or an opaque material such as wood and all, no light passes through. Okay. Any doubt in these three types of materials?
No,
No.
ma'am.
Okay. One. See here also, it's given the three differences. Okay, transparent, translucent, and opaque. Now, there are another type of classification of materials based on how soft or how hard they are. Okay, how soft or how hard they are. For example, some materials are can be compressed easily if we just compress it with our fingers. Our hands can be compressed easily. Some materials are very hard, they cannot be compressed easily. So, those materials which cannot be compressed easily, like a key, piece of wood, steel, metal, and all, okay, they are hard materials. but those which can be compressed easily, like paper, cotton, sponge, etc., are soft materials. Okay, let's do 6.1. Okay, let's do 6.1. The first one, we see a variety of dash around us. Abraham.
Materials.
Yes, Amma. Okay. Next one. Materials exist in dash states. Anna.
Ma'am,
Yes, Abraham.
I have a question about the hard and soft materials.
Yes, Abraham. Ask.
Ma'am, a point that the solid is considered a solid is that it cannot be compressed easily. And now you're saying that materials that cannot be compressed, that can be compressed, such as that cannot be compressed, is called hard materials, and materials that cannot be compressed are called soft materials. But ma'am, a solid cannot be compressed.
Abraham,
And
some solids can be compressed.
ma'am,
Okay.
and ma'am, compression is it means to like in the same area of space, not changing the area, but trying to lessen the space given to it. Even a liquid doesn't compress. Like if you put it in a beaker that exactly fits the shape of the metal, and then you try to compress it, the metal won't compress, and it may break the beaker.
Mm-hmm. That is right, Abraham.
Even if you
Solids are
Play-Doh, or even if you took Play-Doh and it still will not do it. Even sand for that matter, and flour, it would still be rigid, so it would not compress.
oh, okay. Yes, yes, you're saying makes sense. Okay. But
Ma'am, for some
some
materials like sponge and like a sponge, it's a solid, but it can
can be
still
compressed.
be compressed.
See,
See,
Abraham,
a
there are
sponge is designed in such a way that it can be compressed, is because it has a place for air to store, like it stores air in it, so that because air can be compressed, it's got that structure like that. But if you see an individual block, you won't be able to compress it.
okay. So some solids, okay, so we can conclude that there are some solids which are made or designed in such a way that they are compressible. Okay, they can be compressed, but they are still solids. Okay, why? Is because sponge contains the properties of solid, other properties such as it has a definite shape. Okay, a sponge has a definite shape. Okay, and even if like it's not it is a solid, okay, when it is not compressed, okay, then it has that definite shape that it maintains, okay, which changes only when we compress it. So sponge can be compressed because of how it's made, okay, because of the holes in it. Okay, we can take out all its air and we can compress it. But yes, some solids can be compressed. Okay, while most solids don't. Now, Anna, yes. Second one, materials exist in dash states. Abraham, how many states of materials are there?
Materials states.
Yes, I was not able to catch that. Three states, okay?
Ma'am, the
Now,
answer is
third,
three.
Yes, three. Third one, ice is a dash state of material.
Ice is a solid state.
Ice is a solid state of material. Next one, materials which get dissolved in water are called
Dissolvable.
soluble.
Soluble.
Soluble. Okay. Some materials dash in water while others
Materials float in waters while others sink.
float in water while others sink. Yes. And the last one, soft materials can be
Compressed easily.
yes, compressed easily. Now, um, what are transparent materials?
Transparent materials are those which you can see through and all light can pass.
Yes, yes, Emma, which you can see through and through which all the light rays passes. Okay. Can you give one example of transparent, translucent, and opaque materials? All of you. One example.
Ma'am, transparent is like glass.
Yes.
Like when you go to a hotel, they have those like curtains which are like translucent.
Yes.
And then opaque is basically most things. A clothes, anything.
Clothes. Yes. Yes, Emma. Good. Anna, you wanna give examples of these three types of materials? Are you able to speak, Anna? Abraham, your video is frozen for us. Can you hear me?
Ma'am, translucent, a glass cup, transparent, a glass cup, translucent, a balloon, and opaque, a sponge.
Okay, good. Now, then we have another type of material, okay, known as mixture. What is a mixture? When we combine different types of materials, and what comes as a result is known as mixture. Okay. For example, when we make tea, how do we make tea? We combine water, sugar, tea leaves, ginger, okay, all of that we combine and then we make tea, okay. So milk is also there. Milk, water, sugar, tea leaves, ginger, milk, all of that we combine, and then the resultant is tea that we have, that we get at the end. Now, tea is what? Tea is a mixture. Why? Because it's made after mixing all of these components. Okay, all of these things, when we mix them together, we make tea. So, tea is known as mixture. Okay, so when different types of materials are combined together, when they are combined together, they are called mixture. Also, lemonade, that is shikanji, lemonade, that is made of ice, water, lemon, and sugar, and salt also. We put salt. Some people put black salt also. Okay. Then there are separation of materials. How can these materials be separated? This we will cover tomorrow. Okay, we will stop here for today. And 5 minutes break is there for you all, and then we'll continue with math. Okay, hope you all are there. Let's begin. Hi, Nathaniel. Good morning.
Good morning, ma'am.
Yes, ma'am.
Good morning. Okay. So we were doing finding the square root. Did we start with cube root? All right. I think we are yet to start with cube root. Wait a minute. Okay. We were doing some problems based on square root, and today we will start with cube root. Okay. So now, similarly as square root, there is another thing known as cube root. Okay. What is a cube root? Cube root is when I write something such as 2 raised to the power 3. Okay. That is when I'm multiplying a number, when I'm doing its product 3 times. Okay. What I'll obtain is called the cube of the number. Why cube? Because the raised to the power 3 is known as cube. Okay, like we write raised to the power 2 means multiplying it twice, that number twice, it's known as square. When we do raised to the power 3 multiply thrice, it's known as cube. Okay. Now, I will multiply 2 into 2, 4, 4 into 2, 8. So, 8 is the cube of 2. Okay, 8 is the cube of 2. Alright, we can take any number. We can take any number, for example, 5. Okay, means that I'll do 5 times 5 times 5. Okay, 5 5 is 25, 25 times 125. So the cube of 5 will be 125. Okay, understood what is the cube of a number?
Yes, ma'am.
Yes, ma'am.
Okay, okay, all right. Then there are also, like we saw that there are perfect square numbers. There are also perfect cube numbers. Okay, perfect cube numbers. Shall I clear the screen right now? If you're good to,
Yes, ma'am.
I'm clearing it. Perfect cube numbers. Okay, what are perfect cube numbers? Let's pick a number 8. For example, if I have a number 8, so first I'll check that if it's a perfect cube or not. I'll do its prime factorization. Okay, I'll write 8 and I'll start with 2. Okay, 2 4s are 8. 2 2s are 4 and 2 1s are 2. Okay. Now, in 8, I have the factors 2, 2, and 2. So, do you remember that when we used to find square root, we used to make pairs of 2. In cube root, we make pairs of 3. So, this is one pair. Okay, we make pairs of 3. So, this is one pair. Means that 8 is a perfect cube number. Okay, now see, try to understand this. When I do prime factorization of a number and I am able to make pairs 3 3 pairs of 3 3 without any factor leaving behind, without any factor that is left behind, then that number is a perfect cube. Okay, that number are called perfect cube or cubic numbers. Okay, perfect cube numbers are cubic numbers. Take a look at another example. Take a look at another example. 64. Let's do its prime factorization. 60. Start with 2, 3s are 6, 2s are 2, 1s are 2, 8s are 16, 2, 6 are 12, then 2, 8s are 16, 2, 2s are, 2, 4s are 8, 2, 2s are 4, and 2, 1s are 2. Now you make pairs, 2, 2 and 2, this is one pair, and 2, 2 and 2 is another pair. Okay, so is any factor left behind? No, right. 64 is a perfect cube number or a cubic number. So you can write down the definition. If a number can be written as product of triplet. So these making pairs of 3 are known as triplet. Okay? And no factor or pair of factor means 2 is left then such numbers are called cubic numbers. Okay? Let me know once you're done writing and turn on your videos. Everyone, please turn on your videos.
Ma'am, I have a question.
Yes, Nathaniel.
So for a number to be a perfect cube, does it have to have two pairs of three?
Does it have to have two pairs of three? No, not necessarily two pairs of three, but it has to have triplets. The pairs of three are known as triplets. It has to have triplets without any other factor or any two factors leaving behind. It should make complete pairs, complete triplets. Okay, it can have two triplets. It can have three set of triplets. Okay, three and three. Okay, but no factor or no two numbers, they should be left behind. Okay, for it to be a perfect cube number.
Okay, ma'am.
Okay,
Thank you.
okay. Now I want you all to check out for 432 right now. 432. Is it a perfect cubic number or not? Do a prime factorization of 432 and find out, is it a perfect cubic number?
Ma'am, no, right?
Right. Check another one. And check for 512. I'm clearing the screen right now. Check
Ma'am, can you
for,
repeat?
yes, check for 512 if it is a
Yes.
perfect cubic number or not.
Yes, ma'am, it is.
Yes, it is.
Ma'am, yes, it is.
Yes, it is. Okay. Can you tell me 512 is cube of what number? Or what's the cube root of 512?
8.
8. Very good. 8 is the
Ma'am,
cube
I
root.
got 8.
8. Yes, I know. Okay. Now, so these are some numbers, okay, which are perfect cubes, okay, perfect cubes of numbers. Okay. Now we will see how do we convert the cube numbers that are not cubic numbers into cubic numbers. Okay. We will check out the conversion of making the numbers perfect cube. Okay, making any number a perfect cubic number. Now, there are two methods. Okay? There are two methods for it. One is division method, another one is known as multiplication method. Okay? One is division method, another one is multiplication method. Let's take the example of we just did 432. Okay, we just did 432, which is not a cubic number. Okay. Can you list me the factors of 432? That you will get after the factorization?
Ma'am,
Yes, Abraham.
I did it in my mind because I know cubes till 10, so I knew 432 is not one of those cubic numbers.
Hmm. Okay, Abraham. So I'm listing the factors of 432. Okay. 432. Factors are 2 into 2
Ma'am,
into 2. Yes, Emma.
the factors of the
Yes, Emma.
432 I got was 2 into 2 into 2 into 3 into 3 into 3 into
Into 2. Yes, Emma. Correct. Now, we will make pairs. Okay. This is one triplet. This is another triplet. This is left. Factor that's left. Okay. With this, we can conclude that 432 is not a perfect cubic number. Now, look carefully. There are two methods to make a number perfect cubic number. Okay. Here is the multiplication method. Okay. I'll show you both the methods. Here we will do multiplication method. And here we will do division method. Take a look at the multiplication method first. Now I want you all to see that in 432, okay, I had one pair of triplet of 2, one triplet pair of 2, that 2, 2, 2, then one triplet of 3, 3, 3, 3. What was left is 1, 2. Now, how many 2's do we need? How many 2's do we need? Okay, how many 2's do we need for it to become a triplet?
Two more twos.
2 more 2's, right? We need 2 more 2's for this left 2 to become a triplet, right? So that is what I am going to do. I am going to multiply 432 with 2 more 2's. Okay, I am going to multiply 432 with 2 more 2's. Okay, to obtain a number which is going to be a cubic number. Okay,
Ma'am,
yes.
ma'am, the multiplication method is when you find the complete square, find a perfect square. To convert it, you will either round up, or if you don't want to convert it, you will either round down.
You what, Abraham?
Now, see, when you want to convert it in multiplication, in the multiplication method you will round up, meaning like you will go higher. But in the division method, you will go lower.
Yes, Abraham, that's right. Okay, multiplication method, I will find out how many more do I need and then multiply it with that. Division method, I will take what I have and divide the remaining with it. Okay, I'll show you how division works. First, tell me what will be obtained when we multiply 432 with 2 and 2.
One, 7, 2, 8.
Yes, 1728, which is a cubic number.
So, mom, this is
Okay.
Ma'am 1728.
Mom, this is too big.
That's okay. It's too big. It's a
Ma'am,
cubic number.
but 5 and 2 could have come. That would be closer to it.
Okay. Yeah, but it's fine. Like 1728 is fine.
Okay.
Okay, because yeah. Now, next is division method. What we do in division method is that I'll take the remaining factors. Okay. I'm going to take the remaining factors. Or I'm just going to take 432 and divide it with 2. Okay. Just take 432.
216.
Here. Yes. 432. And I'll divide it with 2. Why 2? Because I have only 2 here. Okay. See now. These remaining places we see in division. In multiplication. These two remaining places we see in multiplication method, and what we have, we divide it with that in division method. Okay, suppose I had two twos here. Suppose I had two twos here. Okay, and one two was missing. Then what would I have multiplied with? Only one two. Okay, because what is missing? Only one two to complete the triplet. So I will multiply with 1 2. Now, suppose in division, I have like two twos are given to me. Okay, so what will I do in division? It will become 432 divided by 2 into 2. Okay, or 4. That is how I'm going to divide it. Understood now? The case of triplets.
Yes, ma'am.
Yes, ma'am.
Nathaniel, Anna, hope the case of triplets is clear to you.
Yes,
Yes,
ma'am.
ma'am. Yeah, I understood.
Okay, so write down the answer 216, 216, which is also a cubic number. So you got how with a number that is not a cubic number, we can obtain two cubic numbers. Okay, one we can obtain by multiplication, one we can obtain by division. Okay. Now, I want you all to calculate for 256, which is not a cubic number. Find out the factors, then make one cubic number with multiplication method and make one more cubic number with division method. 256. I'm clearing the screen for this one. 256. You have to make two cubic numbers. Yes. Hope you all are able to do it.
Ma'am, for the multiplication I got 4608 and the division I got 46. See, and for the division I got 9.
9. Okay.
Yes, ma'am. Sorry, I'm on 9. Ma'am, 21.
Let's first do the factorization of 256. We'll begin with 2. 1 is a, 2 is a 4, 8 is a 16. 2, 6 is a 12, and 4 is a 8. 2, 3 is a 6, and 2 is a 4. 2, 1 is a 2, and 6 is a 12, 2, 8 is a 16. 2, 4 is a 8. 2, 2 is a 4. 2, 1 is a 2. Okay, so I have factors. Now I can make pairs. 3, 3, 2 are left. 2 I have remaining. Okay, so in the multiplication, if I list out the factors, 2 into 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 2. And then I make pairs. So what more do I need? 2, 2. Okay, I missed on 1, 2. Big 2 here. And I need one more 2 here for this triplet to complete. So for the multiplication method, I need only one more 2. Okay, I need only one more 2. So with the multiplication method, I can multiply 256 with 2. Can multiply 256 with 1, 2. Okay, the one that is left, the more I need. So 256 into 2, how much? 512. 512, which is a cubic number. Okay, and what else can I do? I can, with division method, can I divide 216 by 2 times 2?
Ma'am, it's 64.
2 times 2. Yes, Abraham, it's 64. Okay. Why am I dividing with 2 times 2? Because in division, I multiply with what I have. And in multiplication, I multiply with what more I need. Okay. In division, I divide with what I have, and in multiplication, I multiply with how much more do I need. Okay. So I'll get, which is a big number. Now tell me how many of y'all got the answer? This answer.
Ma'am, I didn't get the answer because my division, my factorization went wrong.
You didn't got the answer of your factorization? Okay.
I didn't get the answer because my factorization went wrong.
Yes, your factorization went wrong. Anyone who got the answer here in like this answer? Okay. See, when you're doing the factorization, please do it very carefully. Okay. Practice a lot of factorization questions. Do factorization very carefully. Why is that? Is because if your factorization answer is wrong, then the numbers in multiplication method, division method that you will get will be wrong. Okay. The answers will be wrong. You will not be able to locate cubic numbers. Okay. Any doubt till here? Any doubt till now? Anna, Emma, Nathaniel.
Yes, ma'am.
Yes, ma'am.
Okay. Okay. All right. Then let me just give out the homework. Please try out in text questions 3.6, 1, 2, 3, and 4. All 4 questions. In text questions 3.6. Whole. Okay. 3 and 4, the questions 3 and 4 that are there, you have to solve using this method only, multiplication and division method. Okay, they're in the form of problem questions. Try them out today. If you're unable to do it, then I can do it with you in class tomorrow. Okay, I'll explain one in class tomorrow. Okay, try them out. What you have to do is you have to find out the factorization. You have to do the factorization first. Then you have to find out the cubic number using the multiplication and the division methods. Okay. Okay. Any doubt
Yes,
till
ma'am.
here? Any doubt till here?
Yes, ma'am.
Yes, Nathaniel.
No, ma'am.
What is?
I was not understanding the multiplication.
You are not understanding the multiplication method. Okay. So let me explain it to you. See, Nathaniel, first I did factorization. You understood how we did factorization, right?
Yes, ma'am.
Okay. Then we made pairs, okay, of the numbers. Now this is cube. So cube means I have to make triplet, pair of three numbers. So 3 I made one pair, 3 I made another pair. Okay. Now to make complete my third triplet, how many two more do I have? So how many more do I need to complete another triplet? To make
One
another
more.
triplet? One
You
more,
need
right?
one more.
I need only one more. So since I need one more 2, with that 1 2 only I will multiply my original number, that is 256 here. Okay, because I need only one more 2, with 256 I'll multiply that one more. Okay, what I will get is will be my answer, cubic number. Okay,
Yes, ma'am. Now I understood.
Now you understood. Okay. Okay, Anna. See you tomorrow.
Bye, ma'am.
Bye. Bye. Okay, understood the division method, Nathaniel?
Yes, ma'am. I understood the division method.
Okay. Okay, so we will stop here for today. Tomorrow we will continue